Hi! I hope you're doing great. Today, we will discuss a new topic that's called Inscribed Quadrilaterals. This topic is also named as Cyclic Quadrilaterals. Personally, I prefer to call it the second way, but at the end of the day, they mean the same thing. So, first of all, when I refer to inscribed in geometry, usually I am talking about something that's inside a circle. So in this case, an inscribed quadrilateral will be a quadrilateral inside of a circle. And a more formal definition could be any four-sided figure whose vertices all lie on a circle. So for example, if I am referring to this ABCD, this quadrilateral ABCD, you could also say that the points ABCD are concyclic, which means that they lie on a circle. Now, something really important, which is like a property for inscribed quadrilaterals, it's that the opposite angles add up to 180. So here you can look at the angles that are in black, which are DAB and DCB. They both add up to 180, meaning that they are supplementary. Also for the angles ADC and A and CBA, they also add up to 180. This is a really important property that comes out really handy. Now, something else that you can derive from this is the fact that if you know that these two angles are supplementary, and I were to draw a line, an extension of the line DC, like from DC to CD prime, such as you can see it here, and I were to look for the angle ADD prime, which is this angle right here, let's call it an X. Then you know that this angle will be equal to ABC. Why? So let's erase this. This angle will be equal to this one right here. Why? Because you know that these two are supplementary, but you already know that these two are also supplementary. And since this angle is the same, then the remaining angle must be ABC. So that also works if I extended this line right here, the line BA, let's call it BAA prime, then the angle DAA prime would be equal to BCD, which is this one. So basically it's the opposite angle, okay? Now let's do a problem just using what we just saw before. So say you have this quadrilateral, this cyclic quadrilateral. You know that this angle, I forgot to put the vertices A, B, C, D. So say that the angle BCD measures 100 degrees, and you were looking for the angle DAB. Now, you know that the angle BCD plus the angle BAD must add up to 180. And since you already know that BCD measures 100, so let's just solve for the remaining angle, which is BAD. So 100 plus the angle BAD equals to 180. Therefore, the angle BAD equals 80 degrees. So the value of x will be equal to 80 degrees. So let's write it right here, 80 degrees. Now let's do one more problem, which is in the same drawing. So say you have the angle ABC and you were looking for the angle Y, which is ADD prime. So as we saw before, this angle Y would simply be the same as the angle that's opposite to it, in this case ABC. So you know that Y will be equal to 95 degrees. Really simple, right? Now, let's do something else, something that's really important, another property. If I have a quadrilateral like this one, again, an inscribed one, and I were to draw the lines BD and AC, which simply are like diagonals, then the angles that are formed, in this case, ABD, which is this one in green, and the angle ACD are equal. Why? Because they both open up to the same arc, in this case the arc AD, so it's this one right here. And this is a property that's called, well, you know that the angle here is called an inscribed angle. So this angle ABD is the half of the measurement of the arc. And as I said before, they both open the same arc, so they have to measure the same. This happens to all the angles. So in this case, the angle DAC, which is this one, would also be equal to this one. Now, they're equal to each other, but they're not equal to the other one. So say DBC, it's equal to CAD, but it's not equal to DBA, okay? So just simply follow up, the angles that are in the same color are equal, okay? In this case as well, the angle BAC, which let's just do a line in blue, this angle will be equal to the angle BDC, again because they open to the same arc. And finally, the angle BCA, which is this one, will be equal to the angle, yes, this one, BDA. So that is cyclic quadrilaterals.